Okay, I would like to present Dr. Jing Zhao from San Diego State University. She is another expert. Thank you so much, Megan. She's another expert in flavors, and Dr. Jing is more on food applications compared to Megan. Megan is covering the technology, but Dr. Jing will cover on the food applications, how this applies to us, especially in the space of plant-based alternatives. Again, while they settle and tell about plant-based alternatives, is the challenge there because you're trying to mimic something that consumers have a good memory or good understanding of it. So, for example, if you want to mimic tuna and the consumer already have 10 times or 1,000 times they tried tuna, so now you want to create something to their database. That's the tool. I mean, if you're creating flavor for consumers who do not know what is it, it's going to be easy. For example, I want to make artificial durian taste. Nobody will know in the US because very few people tasted durian. Durian is the king of fruits. And that will be easy. But once the consumer have a database, they have something to compare with. It's very difficult. It's like, I'm knowing this. This is not tuna. It's bean. So how are you going to make that taste exactly like tuna? And that's a big challenge. She's with San Diego State University, and she will share with us flavor technologies in the plant-based meat and seafood analogues. So welcome, Dr. Jing.
Thank you very much. So I know I'm really standing between you and the lunch, so I'll try to go over this quickly. Is there a click? Okay, all right, thank you. Yeah, so I know Megan has give a great talk about the analytical technologies. So my talk will cover some of those, but also focus on some of the formulation methods. So we're talking about the plant-based meat, right? Like, so this market has been growing, like, and attracted a lot of attentions. Based on a lot of the market website, the prediction has been very positive. So it shows close to 20% of increase in the market every year due to consumer demands towards sustainability, health, diet, and some ethnical reasons. But in my talk today, I'll focus a little bit more on the challenges this industry would face. So for the plant-based meat products, we know, like, we start with formulation and the processing, right? Like, that's how we put all the different ingredients together, like different ways of extrusion. And then in the end, no matter how successful we are with all these technologies, the success of a product is determined by consumer acceptance. So we need to understand the market and the consumer demand. So this is one study we did 2 years ago in the French market regarding different types of alternative proteins. Like, we look at the different consumer opinions towards, like, the sensory properties, the price, convenience, nutritional properties of several different categories of alternative protein-based products, like a dairy, fish, meat as well. So here's kind of like the main finding from our results. So from, like, on a scale of 1 to 5, you can see most of the consumer ratings are right around the middle circle. So that's around 3, which means neither like or dislike. So that means there's still a lot of space area we can improve in almost all these aspects. So for some product categories, like meat analogs, milk alternatives, the appearance seems to be rated higher. So seems like the products do better in the appearance part. And then one area that was consistently rated low, maybe you have noticed that. What's that? Price, right? So almost for most of the products, the price was rated low. So consumers are not ready to pay for these products yet. Even, like, we just had, like, heard another webinar from a Nestle scientist. So from their, like, a study and survey, even by a 30 cents increase in price per pounds of product, consumers are not ready to pay for that yet for just sustainability. Right? So the price is one part, and also I think related to that is the flavor. People are not willing to pay for something that doesn't have a good undesirable flavor property with increased price. If we look at the flavor rating, so there are slight differences. Some are a little bit higher than others. Like meat analog actually do pretty well. And from the overall consumer preference, you can see even a slight difference in the flavor can lead to a huge difference in consumer preference. Like the one that rated was the lowest was cheese alternatives, which was also rated very low from consumer acceptance. So just coming from that, this kind of like findings kind of aligns with what the goal of GFI. So some of you have heard about the Good Food Institute. They are kind of like a nonprofit organization supporting alternative proteins. In their report, they indicate their theory of change as if we ensure that alternative proteins taste the same or better and cost the same or less than conventional meat while providing equivalent or better nutrition, we can usher like a more sustainable and a just food future. So this future of a plant-based product is very promising, but it's also conditional, right? So we have to solve a lot of things like problems first, and flavor being one of the major part. These consumer perception or like not desirable like flavor properties have some real world consequences. So this is one study a master's student did last year. I'm not going to go into the detail of the study. The point I want to make here is we did this study on the vegan seafood product on the market. We started this project at the end of 2023 and early 2024 by preparing a comprehensive list of all the commercial vegan products on the US market. By the time we do the actual sensory study in fall 2024, 9 of the products on our initial list went off the market. But the good thing is that there are more than 10 new products coming to the market as well. Yeah.
It's something to do with flavor, or it's more
combined reasons,
so
right?
Not
necessarily flavor, but what I'm showing is this is a very dynamic market with a lot of different challenges, including flavor being part of it. So here's just a summary of our main findings if you're interested in looking at them. I won't kind of go into any of the details there. So for my talk today, I want to talk about these 3 aspects, understanding the flavor of flavor compounds in meat and seafood, right? So if we're trying to make vegan meat and the seafood product, this is going to be our goal, the target. And then explore the plant-based flavor formulation. So how can we make plant-based meat and seafood product closer to the actual seafood and meat products? Then lastly, the flavor characterization part. So I'll be quick on that since Megan has covered most of them. So first, for the flavor compounds in meat and the seafood, I know there are a lot of studies out there, right? Like using different analytical methods, different compounds were analyzed and reported, and Megan has explained that depending on the extraction method, the detection method, the results could vary. So I'll show some of the results at the end as well. But just there are some, so I'll introduce 2 database later. So first, the flavor, we know flavor is not just taste. Most of the time people talk about taste, but it also includes the aroma, which is a very important component of flavor, and then the tangential sensations. For taste and the tangential sensations, they are caused by non-volatile compounds. When the compounds dissolve in the saliva, they interact with the like receptors. And for taste, it's relatively simple, right? We know the 5 basic tastes, and we know what compounds are causing that taste. Like sugars will cause sweetness, acids will cause sourness. But for volatile compounds, but for aroma, that's caused by a large number of volatile compounds. Like in coffee, there are close or more than 1,000 volatile compounds which make up the coffee flavor. And it's the type of compounds in there and also the ratio of compounds in there that determines the final composition, a final aroma profile. And also what's making the aroma more complicated is even with the same compounds, like at a different concentration, they give a very different aroma. At low content, for example, some sulfur-containing compounds, they exist in cabbage, in boiled eggs. They could be desirable, but at a higher level, it could be very undesirable. So we have to be careful of not just the type of volatiles in there, but also the levels. So from the sensory perspective, the meat and the seafood flavors are characterized using a series of lexicons developed from research. So for a lot of the products, you can find the published flavor views from the literature. So I just included a few examples here for beef, pork, and whitefish type. So this would be a good start point, try to target what are the goals we try to achieve, right? Which type of flavor we want to target and generate. And then the next question is, if we know what we want, then how do we achieve there? How do we get there? So that comes to the type of volatiles that exist or resulting in these aromas. Here I'll introduce 2 very useful databases. One is a flavor database, FlavorDB. So in this database, it has all the volatile compounds, their flavor, their aroma profile, like what it smells like, and what type of product exists in. Yeah. Yes? Yeah.
This database is only on flavors. Has any link to food process or food industry or associated foods or it's just the database for flavor?
So this database is mainly on the flavor compounds. So it compiles all the flavor compounds out there, but it does have information of what product it exists in. So some of those will be kind of like a raw tuna, some will be processed like a smoked bacon, right? So you can get some information.
So for me as a food scientist working in a flavor company, how can I use this data to understand my customers' needs, my clients' needs?
Okay, yeah, so...
I mean, could I use this database as a food scientist to understand my clients' needs or my processing needs?
So I guess this is a toolbox, right? So if you're trying to enhance certain aroma, you can go in there to see what compounds can help enhance that aroma.
So
right?
It's not only the aroma, but what are the things that enhance or boost that aroma is in there?
So mainly the volatile compounds that contribute to a certain aroma. So not a specific technology that you can enhance, right? But just for example, trimethylamine, that Megan discussed about the fishy odor, right? So if you're looking for some fishy odor, you can search from the database and see this is the compound that we're missing. We try to incorporate.
So it helps you to make conclusions rather than give you an answer.
Yeah, yeah.
If I might add, doing flavor duplication work in a manufacturing facility, it's a bit of art married with science. Sometimes you're really trying to recreate something, maybe just create something in the R&D perspective. So you really are using this as a resource to build out something that you've envisioned or maybe your clients envisioned and bring that to fruition. And the next step in the process of creating a recipe using a database such as this would be to do a panel after, where you have various people maybe eating something or smelling something, and then they give you feedback. And from that feedback, maybe you go back and you do some changes. Maybe someone said, oh, it's overpoweringly buttery. And so, okay, well, I take that information and I go see what chemical components are contributing to buttery. What am I seeing on the GCMS? How is that coming out? Maybe I can even add an internal standard and calculate that chemical component that's contributing to buttery. And then, you can correlate that quantitative data with the database, with your feedback from your panelists, and that gives you a tremendous amount of information to bring something to fruition. And I think that's the most beautiful thing about working in the sciences, is that marriage of creativity, feedback from your team, and the data that you get.
Yeah, thanks, Corey.
We don't want to take your time, but I'll elaborate on that as a food scientist, how you can use all this information. Even though it looks very complex, but I'll draw a roadmap after this workshop that helps you to translate this into language that, as a food scientist, you can use that information, simplify it. So, please,
Yeah.
Dr. Jing.
Okay, yeah, sure. Thanks for the additional explanations. So for this database, another use of it is they have grouped the compounds based on the product type. So for example, I showed this one for beef. So you can choose beef and it'll give you all the flavor molecules in beef. So you can see this list has 92 entries, right? A very long list, a large number of compounds. But it's not realistic to combine all these compounds to recreate the beef flavor. See, most of the flavor houses, they need to also to control this ingredient list, make it simple, and also the cost. They typically compose the flavor with less than 10 compounds. So we really need to understand the importance of these compounds and which one that need to be included. So it's not necessary that we need to include all the 92. But this is a pretty comprehensive list and a useful tool to have. And then another database is the PISCA or Atlas database from GFI website. So this database is only on seafood. So the FlavorDB contains meat and seafood and some other products as well. So in this one, it gives you the different compounds and also the literature, the articles that studied and reported these volatile compounds in the different type of seafood product. So this is another good tool to look at what volatile compounds are in there and going back to some of the literatures there. So that's like we know what compounds are in there, but also importantly, we need to know how these flavors are formed or what precursors plays a role. So in meat and the seafood product, it contains a high amount of amino acids, right? Like it's a protein-rich product, and there are some reducing sugars. So both of these are Maillard reaction substances. So they promote Maillard reaction, which is an important reaction generating some of these flavors. And then nucleotides, which can enhance umami, and also once degraded, it can generate reducing sugar that contributes to the Maillard reaction. Then lipid oxidation is a very important mechanism of flavor formation. A lot of the short-chain volatile compounds are generated through lipid oxidation. Then there are some vitamins and minerals that also play a role. For example, iron that from heme or myoglobin that can catalyze lipid oxidation. So here's just a few examples of the flavor compounds that were generated from different reactions. So next, now we know what's in meat and seafood. What we want to focus on is how we can take that information and formulate the plant-based meat analogs properly, right? So just by comparing the different precursors in the real meat and in the vegan meat and the seafood products, we know in the vegan product, the protein source is different. Instead of having meat, seafood, we use like soy, pea, rice, wheat. These are mung bean proteins. There are some of the major proteins that are used in plant-based products. And then for the lipids, like Dr. Yubin talked about that earlier, in their study, they used the coconut oil, right? But we know in coconut oil, it contains high levels of saturated fatty acids, while most of the oxidation occurs in polyunsaturated fatty acids. So the fat flavor profile is also different. Then in plant-based products, a lot of times we add flavor agents like yeast extract, hydrolyzed vegan proteins. So if we compare these lists, we can see there are some significant differences. So one big concern is the off odor from plant proteins. Like a lot of these pulses, like the soy, they would have a strong beanie odor flavor, which is considered off notes. And then due to the differences in the sugar content and the amino acid composition, like there's also different Maillard intermediate compounds, and the fat composition is different that we mentioned, so it also lacks some of the lipid oxidation products as well. So in this one, I compiled a few studies that show the aroma profile and also the volatile compound in some of the major plant proteins used in vegan seafood and meat products. So, so this table shows, like you can see, most of these plant materials have a beanie or green odor. And then if we look at these specific volatile compounds in the table on the right, these compounds are color-coded based on their chemical groups. There are a lot of aldehyde and ketones in each of these proteins, and some of them, like in pea protein, there are also sulfur-containing compounds. Actually, in rice as well. Rice has the highest amount of sulfur-containing compounds among the plant proteins. So they would all contribute to, like, a little bit off odor, like what we consider off odor in meat product. So here are some of the major sources of the volatiles in plant protein. So some of the volatiles are inherent in the plant. Some are generated from oxidation. Some are generated from oxidation of the sulfur-containing amino acids, which gives the sulfur compounds. And then Maillard reaction, thermal degradation of phenolic compounds, thermal degradation of some pigments, and then also vitamins and some contaminants as well. So besides just the protein ingredient, right? Like once it's going through the processing, like extrusion, then the extrusion process is gonna affect the flavor as well. So like Dr. Yubin has talked about the high moisture, low moisture extrusion, which apply heat, right? Heat would definitely change the flavor profile, and also moisture level as well. So we did the hydration study earlier on. It's very clear a lot of the volatile compounds are formed and released during the hydration process. So comparing to low moisture extrusion, the high moisture extrusion process could help release some of those odors during this process. So on one hand, the high temperature promotes the oxidation and the Maillard reaction, so there will be some new flavor compound formed. But on the other hand, during the hydration process, some flavor would be lost, right? Like be released. So that could be one reason the high moisture products have lower beanie off odor than some of the lower, like low moisture extruded product. So here are a few major flavoring strategies that are used, like including kind of like enzymatic hydrolysis, thermal processing, which is used to promote Maillard reaction, and then fermentation is one way that that can completely change or improve the flavor profile, and then also flavor masking. So for some of these, we have done some projects related to using enzymatic hydrolysis and the Maillard reaction to generate the seafood oil flavor from microalgae. And Dr. Hassan have a project to improve the flavor and functional properties of pea protein in plant-based meat production. We're in collaboration with Dr. Hassan to work on this project.
Just one note, the pH, I think Dr. Jing can elaborate on that, but we observed the pH change structure that published already, but we noticed the flavor profile totally different. It's not because of the acidity, it's the protein conformation change, and the retention of the flavors will be totally different. So that's something to take in consideration in the future. When you are a food scientist out there in the industry, always check the pH. It's a very important factor that we don't really check and we don't fully understand. Especially how does that affect on the reaction and retention of flavors.
Yeah.
Remember protein change, fold, unfold, isoelectric point with pH. So that folding, unfolding have something to do with flavors. Don't ask me what is it, but I know it has something to do with it.
Good point. Yeah, I think I'll touch on that as well. Yeah, so just like quickly, this is one study we're wrapping up on the seafood flavor generation from microalgae. We chose microalgae because those kelp, seaweed, have very similar ocean-ish, like a fishy odor as the seafood. So we utilize Maillard reaction. So this is just a quick review of Maillard reaction, which I'll skip here. For this study, we first hydrolyze the protein and then thermally treat the mixture with and without the precursors, including amino acids and reducing sugar. And then we did sensory and GC mass analysis to look at how the flavor got changed. So just a quick comparison. I didn't include the chromatography, but only the result table here. So from one of the control samples we have, so this one is the hydrolyzed protein treated, heated without any other precursors, and the treated sample are the ones we include external precursors of amino acid and reducing sugar. So you can see here's a short list of like close to 100 compounds we detected. Also, these are the ones selected from sensory-directed study that showed importance in the flavor aroma profile. So for a lot of these compounds, they were detected in seafood, in different type of seafood or products, like shown in the last column. And the ODP results indicate what flavor it smells like. So if you look at these two samples, you can see after the reaction, a lot of new compounds were generated, and those compounds contribute to the seafood odors. Just to go through like the flavor development process. So I'm not talking about the formulation of the plant-based seafood or meat products. This is just about the flavor development. So we start by optimizing the base used for flavor development. So these include some common ingredients, right, like salt, acid, fat. And then after we have appropriate base, and then we'll include like additives to help improve the mouthfeel and the delivery system. So this table summarizes some of the compounds with different functions here. So like for flavor, encapsulation and the delivery is also a key aspect. So the main part I want to talk about is the flavor optimization. So the first two parts are kind of done along with the product development team, right, by the R&D scientists. And then the flavor optimization part is typically done by flavor chemists, or like a lot of times the company collaborate with flavor house and get flavor from them. So for this part, to make the flavor right, we a lot of times adopting masking agent to block some of the undesirable odor, like a bitter, and beanie odor. Yes.
What is the masking agent? You mentioned that like 3 times. I don't know what is the masking agent.
Okay, yeah, so here are some examples. So like anything that can mask the undesirable odor, right? So like sweeteners, it can use kind of like sweetness to suppress some of the off odor. Cyclodextrin, it kind of like traps the hydrophobic volatiles inside so it doesn't release. And there are some other examples here. And also we can use other flavors to kind of like cover the undesirable off odor, like vanilla chocolate. There are some very commonly used ones for not necessarily plant-based meat, but in other products. Yeah.
So they block our tasting buds, or how do they work? You say it's blocker, so
Masking. So masking is different from, I should say like not necessarily blocking. So it just covers up the off odor. So it's like if we add a lot of sugar, it'll suppress the acidity in the
it's
beverage.
more on the taste, not the flavor, not the aroma. You cannot mask aroma.
We could as well, but some of the examples I show here are more for the taste. But for flavor, the aroma, if we enhance a certain aroma compound like vanillin, it can enhance the vanilla odor, and then it can suppress some of the off odor as well. Similar principle. So it's kind of like related to off flavor control. I put them separate because the off flavor control, so the masking agent is more used to mask something that's already there, that cannot be got rid of. And then the off flavor control is typically done to prevent the formation of those off odors. Like for example, like I'll talk about the beanie odor control in the next slide. And also the flavor selection, which I mean is like adding the right flavor additives. Like if we're adding like a seafood flavor to like a plant-based seafood product, then those are the kind of like a flavor additives there. And so just for the off flavor control, we know a lot of the beanie odors are formed through oxidation or Maillard reaction. So one way to control the off flavor formation is to inhibit the oxidation. So one way is to add the antioxidants, for example, ascorbic acid, protein hydrolysis, and also Megan gave the example of adding rosemary to meat products, right? Like all vegan meat products. Rosemary acting as an antioxidant in meat has been researched for decades. I remember when I was a graduate student, it was also a very popular topic. Now people have accepted the rosemary flavor in meat. It's more acceptable, easier for them to accept the rosemary flavor in a vegan meat product. Now, another way to inhibit the oxidation is to inactivate the lipooxygenase. So this is an enzyme that catalyzes a lot of the oxidation reaction. So similarly, like any way that can inhibit the oxidation, prevent the formation of these off odors, would be helpful for the off flavor control. And there are a long list of different approaches. I just include these few. Adsorbent is a good way to kind of like physically control the release of those off flavors. Here's a recent review paper that summarized a lot of technologies that can be utilized for off flavor control. So this could be a paper that you want to go to if you are working on this topic. Then for the flavor, like a selection of flavor compounds to add to the protein, this is actually a very complicated topic. We understand what the flavor compound is, but a lot of times we don't understand how the flavor compounds interact with the food matrix. Especially protein has very strong flavor binding properties. So the final flavor is significantly affected by the structure of the protein, the type of the flavor compounds, and the affinity, the binding affinity of the flavor and the compounds. So for example, these different compounds would bind to protein with different strengths. And also the processing conditions, like humidity level, pH, like Dr. Hassan mentioned, they can all affect the flavor-protein interaction. So just for the sake of time, I'll skip some of the details of the studies. And so here kind of like is a quick recap of how the flavor interact with protein. So protein and the flavor can bind through different forces. Like there's physical trapping, right, absorption, and then there's also reversible binding, including the hydrogen bond, hydrophobic interaction, ionic bindings. And there's also irreversible binding, like through covalent linkage. For example, disulfide bond, that's a very strong linkage that cannot be kind of like easily broken. So when we formulate the flavor, a lot of time, and this is a work from a flavor house, when they formulate flavor, they have to consider the matrix effect. If certain compounds binds with the protein more tightly than other compounds, then they have to increase the amount of that compounds to ensure the released odor aroma matches with the target aroma. So this table summarizes some of the compound-specific protein flavor binding forces. So overall for, aldehyde ketones, these are some of the major flavor compounds. So aldehydes binds with proteins through covalent bonds and hydrophobic interactions as well, but ketones mainly binds through reversible hydrophobic interactions. So these are some of the factors that we need to kind of like take into consideration when formulating the flavors. And for sulfur compounds, they bind through covalent bond, which is a very stable bond. So if this type of flavor is desirable, then we need to carefully evaluate its effect in the matrix. Then to improve the flavor, we can do a few ways, right? We can modify the protein ingredient. We can do the modification at the protein level, or we can modify the processing process. Like Dr. Hassan earlier asked the question, if we can change the extrusion condition and find the right moisture level, temperature to accommodate the flavor. This is a possibility, but very difficult to achieve. From my opinion, extrusion, the main goal or task of extrusion is to make the texture right. To make the texture and the flavor both right, it will be very challenging. But from the protein level, we can do different types of modifications to alter its structure and its way it binds with flavors. Some of the modification methods include chemical, enzymatic, and the physical modifications like hydrolysis, acetylation, succinylation, deamidation. So there's different options we can choose. And then the environmental factors also play a very critical role. Like the effect of salt. We know salt can help release the flavor most of the time. It can increase the ketone volatiles in pea protein, for example, and increase the alcohol, aldehydes, and ester volatiles in in apple juice. So that's some like the previous studies. And then also the pH, right? So this is like one study that's showing at different pH levels, the protein would bind with the flavor compounds at different strengths. Yeah, so lastly, for the flavor development part, once we have the flavor developed, we also need to consider its delivery technology. Do we want to deliver the flavor as liquid or the powders? So I brought in some samples in both forms. So there will be some liquid flavor and some powder flavors that you can look at tomorrow. So for the liquid flavors, like we need to also consider if it's water-based, right? Water-soluble flavors or oil-soluble ones, or is that like emulsion-based? For powdered ones, we also need to consider if it's encapsulated, freeze-dried, or like plated, or if it's a combination. So lastly, just very briefly, I'll go over kind of like the flavor characterization methods. So luckily, Megan has talked about most of the instrumental analysis. So for the flavor study, we have the instrumental analysis, which I will talk about, but also sensory evaluation is very important too. And we use all those equipment technology, right? Like including the analysis for texture and flavors, volatiles. The purpose of all those instrumental analysis is try to mimic or understand how humans interact with food. So the sensory evaluation is still the golden standard, the goal we want to achieve. So for sensory evaluation, I think most of you are familiar with the 3 major categories of sensory evaluation: discrimination test, descriptive test, and the consumer test, right? So which is also called acceptance or preference test. The discrimination test is used to look at if two samples are the same or not. It only provides very limited information. So a lot of times during product development, we use descriptive tests to understand which area needs improvement, how the properties, sensory properties vary among different samples. And then also utilize consumer testing to understand the consumer preference and responses. Then lastly, here's one, the temporal flavor analysis. This analysis look at the time effect of the flavor, because like the flavor is going to change during shelf life, storage, or sometimes it can change very quickly in a few minutes, kind of like the front odor, after odor, like the front notes and off notes of the aromas, right? So this will be something I'll talk about more in tomorrow's demo. So we're gonna go through a practice run of how we train the panelists, and then how to set up the sensory evaluation using RightJade. So previously we've been doing a lot of like sensory evaluation on papers, collecting the questionnaires, but now almost everything moved to electronic. So this will be, I'll talk more about these during the demo session tomorrow. And for the instrumental analysis, Megan has talked a lot about GC-MES-O. So this is also the technology we use in my lab. So in some labs, it's set up as a GC-MES and GCO as two separate equipment. The beauty of combining this into one is we can correlate the odor with the compound being detected. So I won't go through this again. So basically the GC is a separation technology that separates the compounds to generate different peaks. And through a splitter, we can direct a portion of the volatiles to mass spectrometry. So it just shows different peaks and with the mass over Z information. And then another portion would go to the sniffing port. So we can control the percentage of compounds, volatile compounds, goes to each detector by changing the length of the tubing. So in our study, for compound identification, we use a combined information from the mass over Z, the mass detector. So we utilize NIST library for that. We also analyze and calculate the RI, the retention index, to help to assist with compound identification, also in combination of the aromas being detected from the ODP. But with GC and for volatile analysis, there are some other detectors that we can utilize, right? So basic gas chromatography is a separation technique. Both mass and olfactometry ODP are detectors. There are some other detectors that can be utilized for volatile analysis, like a flame ionization detector and ion mobility spectrometry. So the IMS has gained some popularity. You can see more and more literatures reporting results from this methods now. So this is the setup of the GCMS in my lab. So that's the oven which houses the columns inside. So that's where kind of like the temperature ramp, like the chamber will be heated and the volatile compounds will be separated as the temperature increase. The left side is the mass spectrometry, which has a pump connected with it to create the vacuum. And the right portion, that's ODP. So what's not shown on that, we also have the TDU and the CIS, which Megan has explained. So this will be the TDU unit, the little red box, and the CIS is actually underneath it with just like a change of the inlet. The CIS, the cooled injection function, is achieved by the connection with the liquid nitrogen tank, so through these like black wires. Yeah, so these are some of the sampling methods that like Megan has discussed, so I won't go through this again. But overall, there are two major categories. The head space method, which we directly get the volatiles in the air phase. So the injection will be through like just gas injection. And then we have the solvent-assisted method. We extract the volatiles with solvents, and then the injection will be through liquid injection. So different methods can lead to different results. So that was a very good question from Dr. Hassan. What method to choose? For our analysis, for every time we deal with a new sample, we have to go through method development. Like even for SPME, there are different fibers we can work with. Like Dr. Yubin also asked about like the affinity, right? So different fibers have different affinity to different compounds. So some volatiles are more likely to be concentrated on certain type of fiber. So we also have to go through different types of fiber to choose the optimal one to work with. And this just shows a comparison of the volatile analysis results using different sample extraction methods. So from SAFE, which is a liquid extraction method, some of the compounds highlighted in purple are detected in large quantity, while in Purge and Trap, they detected another group of compounds, while in SPME, that's another group of compounds. So you can see how significant the extraction method can affect the analysis. So it's definitely a challenge. Then for the results, we can express the volatile results using a few different ways. The relative peak intensity is very often used and reported in the literature. So that's like they use peak height or peak area. So it can give us some information, but it's not actual quantification. Then some studies report the relative intensity, which compares to the kind of like the maximum intensity detected. Then we get to the quantification, which we can actually quantify the concentration of the volatile compounds, either in the air or in the food matrix. So for quantification, there are two ways. We can use internal standard for semi-quantitative analysis, or use external standards for actual quantitative analysis. But the challenge of doing quantitative analysis is we have to build the standard curve for each individual compound. So you can imagine if the product contains 100 compounds, it's not possible to create a standard curve using the actual standard for each of these compounds. So in actual analysis, we either do non-targeted analysis, which is mainly to characterize what volatiles are in that product. So for that purpose, we typically don't do the quantification using external standard. And then we also, another type of study is using targeted analysis. So, for example, for the fishy odor, right? If we want to track the fishy odor in a product, we can track the amount of trimethylamine throughout the storage process, and we only focus on that specific compound. So that's the targeted analysis. For that, we can build a standard curve just for that compound and keep track of that compound. So that's one way to do the flavor analysis. And then once we know the concentration, we can calculate the odor value based on the odor threshold. So as Megan has already introduced, sometimes it's not the actual amount of the compound that matters. It's more of the odor value, how big an impact it has in a food matrix. So here's just one example. So that's from a study I did a while ago during my postdoc. So we analyzed the flavor profiles of different commercial rice protein. So you can see in these, just like what I want to highlight here is if we look at the methyl and the pentanol actually exists in much higher content, right? It's about 7-8 times more, but its odor value is only 1. So it's barely detectable. But for methyl, its odor value is 8. So it's a more significant contributor to the flavor of the compounds. So just lastly, I believe this is the second last slide. So this is circling back to the tuna study I introduced as like the vegan seafood study I mentioned earlier. So this is a comparison of real tuna product with some of the vegan tuna product. It's interesting, like Gersto did a similar study on tuna, so it seems like it's a favorite of research. So you can see just by generally looking at the spectrum, you can see there are some common compounds exist in both vegan and the real tuna version. There are some off flavor only in the vegan products, and there are some products in the real tuna that is missing in the plant products. So lastly, besides GCMS, electronic nose is another technique that have been adopted. This technology doesn't characterize the individual volatile compounds. It only it uses the sensor to group the volatile compounds. So it can tell us what's the amount, like aldehydes, acids, pyrazine molecules in there. So lastly, here's a summary. So flavor is critical, but it's also very complex. I mean, I'm studying, Dr. Hassan keeps emphasizing he doesn't know much about flavor, even though I've been working with flavor for many years. I still don't know like everything about flavor. It's just a very complicated topic. So for future direction, I think with all the AI technologies available, it would be a very useful tool to use AI-driven predictions for flavor development in the future. And also fermentation will be a very important tool to kind of alter the flavor. All right, so with that, thank you.
Thank you, Dr. Jing. We're not going to stop here. We could continue the questions during the lunch. We have about 45 minutes until we move on to the hands-on sessions. We will start about 1:30. And I will help the groups to go around and find where are the training stations, the hands-on. We're going to switch from group 1, 2, 3. I'll tell you now the names of the groups, the people in the group, in each group, and who was the group leader. As I promised, it seems to be really complex. It is really complex. Even though 18 years in the field, or maybe 20 years in the field, I'm more younger than you. Maybe 15 years, you are younger than me. So 15 years in the field, but it's really complex. It's not only to us as scientists and researchers, but even in food industry. And I think you could check with Christine and Holly. They can tell you stories from food industry. It's not easy because you are combining multiple ingredients and multiple subfractions in one melting pot, and you want to create something tastes good, smells good, meet the consumers, and very cheap, and organic, and no artificial. It's like that's too difficult. So I will create a roadmap, and by the way, we will share all these slides with you later on, the recorded lectures. It's going to be shared with all the participants and the sponsors. And I will create a roadmap to simplify how you position yourself or how to follow steps or checklists to combine the process, the flavors, the structure, between the process and the effects on the final product. So how do I make a decision? I will make a very simplified roadmap that helps you as a students and future food scientists in the food industry. For now, I have some printed agendas in here. I'm against the printing, but my student already did print it. Good thing they did it double side, so that's okay. Okay, don't feel so bad. But let me assign the groups, then we can have the lunch, and then we move on with the hands-on. Group 1 will be starting with the extrusion with Lucifer and Carolina upstairs. Group 2 will do the analysis with Dr. Yobing, and 8 will be on the 117. And Group 3 will do the work with Megan and Corey and Dr. Jing at the chemistry lab for the hands-on for the flavor analysis. And I will be helping you in 1 hour or 45 minutes to switch it from group to another group, so you all have the 3 trainings. And we can meet here at the end and we wrap it up. We have some questions and we call it the day and we start tomorrow again. So group 1 is Christine. You are the group leader. Oh, sorry, I'm so sorry. Christine, you are the group leader. You have Suvani, you have Michael, you have Cynthia, you have Samir, and you have Shirley. And group 2, Ollie, you are the group leader. You have Cami, you have Jack, which unfortunately is not here. You have Elizabeth, and you have Denia, and Heath. And group 3, we have Rasul, who is not here today. So I guess Samir, you are you are already in there. So okay, we're missing some person in here. So the group will have Lucine, Yutin, and Kirtana, and Jesslyn. And could we move Samir to be the group leader of group 3? Because the person, yes, okay. So do you want to get the names? Yeah. Lucine, Yutin, Kirtana, and Jesslyn. So you will be working with Samir, and yeah, you will be group 1, starting with extrusion, group 2 with the analysis, and you are group 3, we do the flavor, and then we switch. Great. Any questions? Anything is not clear? We're done with the tough part, which is lectures and theories. Now is the fun part. We will see some products, we will test it, smell. Yeah, it's safe for consumption, but we don't take any responsibility. So. But as a pea protein, so no allergens, gluten-free, and you can take home some of it to cook with it, so give us the feedback. And one last thing, I would like to welcome Dr. Gabriel Davidov. He's a food scientist in our department. Unfortunately, he became the associate dean, which is fortunately, yes. I mean, we lose 20% of our working force, and one of our senior professors who developed the product development, which actually is the peak where we combine all this, what we're talking about, the structure, the texture, the flavors in that course. He's the associate dean now, but he's still a food scientist. He cannot, So he's joining us for the lunch, and if you have any questions for him or any of us, we will be more than happy to answer. Enjoy the lunch. I hope you like it, and yeah, we'll see you at 1:30.